operations composition. So we're going to do operations on function. Just like how we add, subtract, multiply, and divide real numbers, we can do the same with functions. This is what the notation looks like. So when you see this, f plus g of x, that means f of x plus g of x. F minus g of x equals f of x minus g of x. F times g, likewise f times g. F over g, f divided by g. And this is the only one where you gotta watch out, g cannot be 0. I do want to point out that x here is just the variable we're talking about. So it could be w, it could be z, it could be a number, it's just the thing you're plugging into the function. Nothing special there. So let's do an example or two. Use let f of x equal x squared plus 1, g of x equal 3x plus 5, perform the operations given. So f plus g at 1. So we'll explain what that at 1 means in a second. But f plus g, they just want us to do f of 1 plus g of 1. So f of x, so we're going to do x squared plus 1. Right, that's my f function, and then we're just going to add that to my g function, 3x plus 5. Now what the 1 does is just they want us to substitute 1 in for x squared. Sorry, 1 in for x, not x squared. So wherever there's an x, you plug a 1 in. X squared plus 1, 3 times 1 plus 5. Over here I get 2 plus 8, so my answer is 10. That's the value. Same thing here, f minus g at negative 3. So we're going to do f, which is x squared plus 1, minus g, which is 3x plus 5. And they want us to substitute in negative 3. Now negative 3 squared, remember the square's on the outside, so you square negative 3, it gets us 9. 9 plus 1 is 10. Over here I get negative 9 plus 5, which is negative 4, so minus negative 4. Two negatives make a positive, so I get 14. The next one, f times g, so don't want to multiply it, x squared plus 1 times 3x plus 5. Now again, instead of multiplying these out, I'm just going to substitute 5 in, which it wants me to do. So 5 squared plus 1 times 3 times 5 plus 5. You get 15 plus 5, which is 20, times 25 plus 1, which is 26. I'm going to get, what is that? 520. Just like that. Then f of g of 0. So again, same idea. We're going to do f, which is x squared plus 1, over g, 3x plus 5, and now they want to substitute in 0 for the x's. So that's going to be a 0 squared, that's going to be 3 times 0, and we get 1 over 5. So that's operations when there's a number inside of there. Just plug it in. Now again, it's easier to plug in once you separate it and figure out what you're doing. Plug it in there. You don't have to like simplify it all the way down. Just plug it when it's most opportune. Now we're going to use operations of functions to simplify these, but notice that they don't have an exit. They don't have a number in these. We're just going to simplify as best we can. So let's do a over here. I'm going to do f of x plus g of x. Right, that's what this symbol means. I want to add that plus g. The x is just the variable we're using. So each one of these is an x. That's all that means. So 8x minus 9 plus g, which is radical 2x plus minus 1. And they want me to add them. I can't do anything else. 8x minus 9 plus radical 2x minus 1. That's it. Can't do anything else. B, f minus g, so similar idea. F is 8x minus 9 minus g, which is radical 2x minus 1. And again, there's nothing else I could do. It's just the way the answer is. C, they want me to multiply them. So 8x minus 9 times rad 2x minus 1. I guess this one I can distribute. There's not really much to do. Probably distributing this way. But honestly, I'm just leaving it at that. I think that's a better answer. There's nothing else I could do. That's that. D, f over g, so 8x minus 9 over radical 2x minus 1. So there we go. Evaluating a combination of functions. So what's going on here is we want to evaluate these function operations, but we're going to use this picture here, this graph, to find our values. So look at the first one, f plus g. So remember, if I was going to break that up, that is f of 4 plus g of 4. Well, how do I find f of 4? I have a graph right here. At 4, my f is 9. So 4 just equals 9. At 4, my g equals, looks like 2. So this is just 9 plus 2, which is 11. Done. The next one, we have f of negative 2 minus g of negative 2. We're going to do the exact same thing. We're going to go negative 2. On my f, I get this value here, which is negative 3. And g of negative 2 does not exist. Here's g, there's no negative 2. So this is you can't do it. Not possible. That's why it says if possible. There's no g of negative 2, so you can't do it. Next one, f times g of 1. So again, all this is f of 1 times g of 1. Here's 1. F of 1 looks like it's 3. And then here's 1, and g of 1 would be right here, which is 1. So I just get 3. And then next one here, f of g of 0. So it's just f of 0 over g of 0. F of 0 is just for the origin. So remember x equals 0, so f of 0 would be 1. And then g of 0 is the red line, and that is 0. Well, we can't divide by 0, so this does not exist, or undefined. Undefined is better. So there we go. So that's how we do composition functions, but using a graph. Now we can do the same thing using a table. I'm not gonna go through all of them, so I'll do a couple of them. So let's do f of 4 plus g of 4. Well, to find these values, all we have to do is look at the table. Here's x. Here's my x value, and then here's what f of 4 is, and here's what g of 4 is. So this will be 9 minus 2, so which is plus 2, which is 11. And then do f times g, f of 1 times g of 1. Right? Here's 1, and then f of 1 is 3, g of 1 is 1. So 3 times 1 is 3. And then, so I'm showing 3 ways to do it, right? So first way is like, if I give you a graph, you should be able to find the values. If I give you a table, you should really be able to find the values. And what if I give you equations? Well, we'll do these two. We've done this already. These are the values. So f minus g, that just means the f function minus the g function. F is 2x plus 1. G is radical x. And then we substitute our value at negative 2. So I get 2 times negative 2, negative 4 plus 1, minus square root of negative 4, negative 2. Which I cannot do because it can't take a square root of a negative, so not possible. F of g of 0. So we're going to do f of 0 over g of 0. So that's going to be 2 times 0 plus 1 over square root of 0. And another one we're dividing by 0, which you cannot do, so undefined. Oh, this was a graph. If we get the same answer, no duh. That's why. We have the same answer, because it was a graph. That's why f of negative 2 was not possible. Should have saw that earlier. Anyway, let's talk about composition functions. This is a fun one. This is where you plug one function into the other function. As you can see here, this is called g of f. That's how you read this. G of f. So this g of f is the same thing as saying g of f of x. Right? Those two notations are equivalent, and you can see that here. So how do you do this? Well, you're plugging the inside function into the outside function. That's kind of the key. So that's what we're going to plug in. We're plugging our inside function into the outside function. Let's do a couple examples. So we're going to evaluate this. I want to find what f of g of 2 is. Now this has a number. And when you do a number, there's actually an easier way to do this, which is you do this inside number first. Figure out what g of 2 is. Super simple. Just plug 2 into g. So 4 over 2 minus 1, which is 4 over 1, which is 4. So g of 2 equals 4. Good. Now I know what g of 2 is. You can kind of like cross this off, and that is 4. So if I want to solve this, all I gotta do is solve f of 4, which is just plug 4 into the f function. I get 8 minus 1, which is 7. So that's the answer here, 7. Right? I substituted 2 into the g function. I got a value, which was 4, and I substituted that answer into that function. I got 7. So that's how you do it when you have a number. So we're going to do it one more time, make sure we got it. Right, I'm going to do this first. So I'm going to figure out what f of negative 3 is. So we're going to substitute in for f. Again, negative 6 minus 1 is negative 7 this time. So I get negative 7. I'm going to substitute that into the outside equation here, g. Remember, this part's gone now. This is negative 7. So all we have left is g of negative 7, which is 4 times negative 7 minus 1, which is 4 over negative 8, which is negative 1/2. So there we go. That's how you evaluate a composition of function with value. Well, what if I don't give you a value? Well, in this case, you just want to plug your inside function to your outside function. So I always tell myself, what's the outside function? So for a, I'm plugging f into g. G is this thing. So all I'm going to do is wherever I see an x, I'm going to leave that as a space. So it's going to be 2 of something squared plus 5 times something. This is what g of f of x equals. Right? Because that's what g is. G is 2 times something squared plus 5 times something. What's the something I'm plugging in? That function, which is 4x plus 1. And you could simplify if you want to. I'm going to leave it like that because I think that's the way the book leaves it. So you get something like this. Right? I'm plugging the f function into the g function. Now let's switch it. We're going to plug the g function into the f function. So in this case, I'm going to figure out what f of g is. Remember, f is the outside. So what's that function look like? It looks like 4 times something plus 1. So 4 times something plus 1. What's that thing we're plugging in? The g function. That g function is all of this mess. 2x squared plus 5x. So there we go. We could leave it like that again, or you could simplify. This one you can simplify without much fanfare. That's what my function equals. So that's how you evaluate without a number. You just plug one function to the other function, you get your answer. Now if you had a number, you could also do it this way and then at the very end plug your number in, but I think it's a little more work than just working inside out. Get the first value first, then plug into the second value. This one's going backwards, finding functions of composition functions. So what they're saying is we have this long function here is an f of g of x. And I want to figure out what f of x is and what g of x is. So in this case, g of x is the inside value right there. So what's the one that's getting plugged into the other one? What's the inside value? I would say it's this and this. 4x minus 5. X squared minus 5. Right. That function is inside this other function here. You can see how like those two match inside this function. What are they inside of? Well, the function looks kind of like this. X cubed minus 4x plus 3. Right? If you take this function out for g, then what's left over? A giant variable cubed minus 4 times the variable plus 3. Let me get this. So that's kind of how you work backwards. Right? There's lots of different answers for this actually. You can do this lots of different ways. The general way is like, okay, that's on the inside. That's my g in this case. What's left over when you take that out? Placeholders, which are x's, so x cubed minus 4x plus 3. The difference quotient. So this is a little preview to calculus. So the difference quotient is a fancy name for this guy right here. So that's the difference quotient. F of x plus h minus f of x all over h. Now the tricky part for most people is this right here, x plus h. Now if you understood this, right, plugging one function to the other function, it's the same concept. Whatever my x is, I'm going to plug in, instead of x, I'm plugging x plus h. So it looks a little weird. Let's do one real quick. So actually all we want to do here is figure out what f of x plus h is. So that's all they want. All they want is, what is f of x plus h? Well, if you look at my function here is x squared. But really what that is, it's something squared. Right? That's all x is. It's a placeholder. It's something squared. So actually, let me erase. I don't like the way that's done. I'm going to do it like this. And what are we plugging into that something? And here they plug in x and you got x squared. And here we're plugging in x plus h. So you should get x plus h squared. So that's how you read that one. You plug in x plus h instead of the x. B has two values. F of x equals 2x minus 5x squared. So again, the way I see that is f of something equals 2 times something minus 5 times something squared. What that something is, in this case, is x plus h. So where I have that space, I'm plugging x plus h. And there's my answer. Again, if I want to simplify it, but that's the general rule of how you just do x plus h. Wherever there's an x, you just plug in x plus h instead of x. Now the last thing we do is we're going to find the difference quotient of this. So remember, the difference quotient is this formula, f of x plus h minus f of x all over h. Now, the hardest thing, like I said last time, is f of x plus h. How do I do that? Well, here's my function. And I want to plug in x plus h. So wherever there's an x, it's just a placeholder. And that's where I get to plug in my x plus h, right? It just goes in, instead of x, it goes in for that space, x plus h. Now if I'm going to simplify this, because I do have to simplify it, it's not x squared plus h squared. Don't forget when you square something, you multiply it by itself. It's x plus h times x plus h plus 1. And when you simplify this, you get x squared plus hx plus hx. Remember, these don't really matter, it's just alphabetical. So impact of x times h, the same as hx plus h squared plus 1. So I have all that. That's all this right here. Actually, let me simplify. I can add the middle two terms. I get x squared plus 2hx plus h squared plus 1. Remember, all of this is just the f of x plus h part. It's only this part. But that, luckily for us, that is the hardest part. So let's move on to the second part of this. So I want to change this with all that stuff I found. So we found that all of this was x squared plus 2hx plus h squared plus 1. Then we're going to subtract off f of x. So minus, what's f of x? That's what the function you start off with. That is literally the guy right here. That's what we started off with. So don't forget the parentheses, very important, x squared plus 1. Because that's what our original function was, this guy right there. And all we have to do now is simplify and see what happens. Very important this is in parentheses because we want to distribute. We're going to get x squared plus 2hx plus h squared plus 1 minus x squared plus minus 1. And negative gets distributed to both of them all over h. Now if we see this, a couple things cancel if you did it correctly. Basically everything on the f of x should cancel. X squared should cancel out with x squared, and then 1 should cancel out 1. And we're left with 2hx plus h squared over h. And then here, I could actually still cancel these. The top all has an h and the bottom has an h. So you pull out 1h, and you get 2x plus h all over h. Those will cancel, and I get my final answer, 2x plus h. And that's the lesson.